When you're dividing polynomial rational expressions, you're basically doing the same thing that we did when we were multiplying polynomial rational expressions. We are going to end up factor, 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 cancel out common factors. But before we get to that point, we need to change the division into multiplication. We do not divide fractions. You learned this a long time ago. Don't divide fractions. Instead, multiply by the reciprocal. In my old school, my students in middle school, they learned the phrase Kansas City football, KCF. So Kansas City football, KCF, means keep the first fraction the same, change the sign to multiply, flip the second fraction, which is a middle school way of basically saying, instead of dividing, multiply by the reciprocal. So you're going to keep the first fraction the same. So I'm going to rewrite this, 5x over 3x minus 12. Instead of dividing, we are going to multiply by the reciprocal. Reciprocal means flip the fraction. So x squared minus 6x plus 8 is going to be on the top. X squared minus 2x is going to be on the bottom. Now, this problem is exactly what we did yesterday. We need to factor, 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 cancel out common factors. So I'm going to draw one fraction bar and then start working at this piece by piece. So 5x, we can't really factor that, so 5x is one of our denominators. One of our numerators. Whew, almost screwed that up. Our second numerator, x squared minus 6x plus 8. We are looking for two numbers that multiply to give us 8 and add up to negative 6. So 2 and 4, they'd both have to be negative. And again, if you feel like the only thing that's holding you back from this making sense is that you're not a very good factorer, you're not very good at factoring, please come see me during Wildcat Hour. I will help you factor. Or if you have a graphing calculator, I can teach you how you can use that to your advantage with factoring. Okay, our first denominator, 3x minus 12. How do we factor 3x minus 12? The two terms have 3 in common, so we put 3 outside of the parentheses. If we divide, quote, divide, you're unmultiplying. If you factor out a 3 from both of those terms, you'd be left with x minus 4 in the parentheses. Then, how do we factor x squared minus 2x? Take out an x. So they have x in common, x minus 2 in the parentheses. Now's the fun part. Now we get to cancel stuff out. So what cancels? X minus 2, x minus 4. Does anything else cancel? The x. The 5x on the top is not 5x. It's 5 times x. So we can cancel out the x's, and the only thing that's left now is 5 over 3. Take a moment, pause the video. Try number 11 on your own. Once you're done, play the video to check your answer. Okay, your first step, we do not divide. Instead, we multiply by the reciprocal. So you keep the first fraction the same, you change the sign to multiply, and then you take the reciprocal of the second fraction. You flip that second fraction. Now we need to factor. So my first numerator is a 3. That doesn't factor anymore. My next numerator is x squared plus x minus 6. We are looking for two numbers that multiply to give us 6 and add up to 1. So that's going to be 3 and 2. And for it to add up to positive 1, the 3's needs to be positive, the 2 needs to be negative. Our first denominator, 4x minus 8. Anytime you have only two terms, check for difference of two squares, but it's usually greatest common factor. So 4x and 8, they have 4 in common. 4x divided by 4 is x. Negative 8 divided by 4 is negative 2. And my last denominator, those two things have x in common. Now the fun part. X minus 2 cancels, x plus 3 cancels. So the stuff that's left is 3 on the top and 4x on the bottom. So our final simplified answer is 3 over 4x. In number 12, we have a fraction divided by something that isn't a fraction. So we're going to turn this thing into a fraction by putting it over 1. And then instead of dividing, you keep the first fraction the same. You multiply by the reciprocal. So if we flip that thing, we end up with the 1 on the top and the 4x squared minus x on the bottom. If you know how to factor, you would be able to then factor each part of this and cancel things out. For the sake of time, since we're at the end of the school year, we are going to skip this type of problem. Do you notice there's an 8 in front of the x squared? So theoretically, I taught you how to do this kind of factoring. And if you go back to first semester and find the factoring videos, you can watch how to do this kind of factoring. If you're going into college algebra or pre-AP calculus and you want a refresher on factoring, come in and I'll gladly give you one. But for right now, we're just going to say, this is how you would start this problem, and then assuming that you know how to factor, you could finish it. We're also going to skip this one. So turn the page. First thing we're going to talk about for this section, I would like you to remember back to whatever grade you were when you learned this. If I have 2/7 plus 3/7, what do I have? 5/7. Why did you not add the denominators? Okay, when you're adding and subtracting fractions, you have to have common denominators. If the denominators are the same, all you do is add or subtract the numerators. So that's basically what we're going to be doing. We are adding and subtracting rational expressions. So we have 4 over 3x plus 5 over 3x. Do you notice that the denominators are the same? So all we have to do is add the numerators. 4 plus 5 is 9. So 9 over 3x is your answer. But do you notice that 9 over 3x could be simplified further? So what is 9 divided by 3? 3. So our answer is 3 over x. Okay, try number 2 on your own. Okay, so x minus 4 matches in both denominators, so all we need to do is subtract 5 minus 8. What is 5 minus 8? We are going to save number 3 for tomorrow. We are going to work on number 4. What do you notice about number 4? They are not the same. So, first thing that we need to do is see what we have. So our first fraction is x plus 1 over, we need to figure out what this denominator actually is. Let's factor this denominator. So we're looking for two numbers that multiply to give us 9 and add up to 6. That would be 3 and 3. So that first denominator is x plus 3, x plus 3. Leave yourself some space. And then because this is subtraction, I'm going to attach the negative to the 1 on the next fraction. How do we factor x squared minus 9? It's a difference of two squares. It factors into x plus 3, x minus 3. If you're having trouble recognizing difference of two squares, think about this as the x term is missing, so this is x squared plus 0x minus 9, and that may help you to see how the numbers are positive 3 and negative 3. Okay, we need to make the denominators match, and before we do any more, I want to remind you, if we had 2/3 plus 3/4, how would you do the addition problem 2/3 plus 3/4? What would be the common denominator between 3 and 4? 12. So to make the 3 become a 12, we'd have to multiply by 4. But do you just multiply the denominator by 4? You also multiply the numerator by 4. So that would give you 8/12. To make the other fraction match, we would want to multiply by 3 on the top and the bottom. That would be 9/12. We're going to use that same strategy, but instead of 3's and 4's, we're going to be using x plus 3's and x minus 3's. So let's see what currently matches. We've got an x plus 3 and an x plus 3 in both denominators. So I'm going to put a little check mark underneath them once I know that they match in both denominators. Okay, my first one has an another x plus 3, but does this second fraction have another x plus 3? So we need to multiply x plus 3 on the top and the bottom. Now, both denominators have a second x plus 3. The second fraction has an x minus 3. Does the first fraction have an x minus 3? No. So to make these match, we need an x minus 3 in the first fraction. And you need to put parentheses around your original numerator to make that all work. Okay. Our common denominator is going to be x plus 3, x plus 3, x minus 3. The order doesn't matter as long as you have 2 factors of x plus 3 in there and 1 factor of x minus 3. That's what both denominators have. Now that the denominators match, all we have to do is add or subtract what's in the numerator. But that's going to involve some multiplication. We need to FOIL that first numerator. You guys know I don't like that word, but whatever. We need to FOIL. So you could do this step by step. X times x is x squared, negative 3x, x minus 3. Or use what you know about factoring to multiply that faster. When you multiply x plus 1 times x plus 3, your first term is going to be x squared. Your second term, if you add those two numbers together, 1 plus a negative 3 is negative 2. So our middle term is negative 2x. The last term, you multiply those together, that would be, negative 3. Okay, so by multiplying out x plus 1 times x minus 3, by multiplying that first numerator out, we got x squared minus 2x minus 3. The other numerator is negative 1 times x plus 3. We have to distribute. So that would give us negative 1x minus 3. What do you suppose we have to do in our numerator now? We combine like terms. So we have x squared minus 3x minus 6. Our denominator, do you notice we have 2 factors of x plus 3? So x plus 3 squared, x minus 3. The one step that's commonly forgotten, but it's commonly forgotten for a good reason because you normally don't have to do anything, but you should check, does this factor further? Because if this numerator would factor and end up giving us an x minus 3 or an x plus 3, then we could cancel. So let's just check for a minute. We need 2 numbers that multiply to give us 6. You can do 1 times 6 or 2 times 3. Would either of those pairs of numbers add up to negative 3? No, so it's not going to be factorable, and this is your simplified answer.